Hello, everyone. Thank you guys for coming in here today. We're going to be talking about testing today, and I will give you lots of reasons why, especially in today's world where one of the early adoptions for AI, I feel like, is like, let's just have AI write all the tests. And I want to just start with a disclaimer that I picked up Danny's book yesterday. I was thumbing through the table of contents, and I saw one of them said like safety recall warning. I was like, that's kind of weird. I'll look that up. And it's like the first thing I read in this book. And it's a little blurb that says, do not let AI write anything that you don't understand. So yes, we live in a world where AI could very simply write a lot of your unit tests for you, but they need to be tools. They need to be templates, and you have to know what that's actually testing. All right. So that's my little AI pitch today, since it's such a common thing in today's world. A little bit about me. I'm a husband. I'm a father to two wonderful children. That little guy right there turns 8 months tomorrow. He started crawling 2 days ago, which means that my wife and I no longer know peace. So that's fun. I'm a software engineer at Liberty Mutual Insurance, just down the road. They have a headquarters building. And I just want to give you a little bit of context about what my team does at Liberty, because I think it's relevant to my talk today. My team handles the metadata for all of Liberty Mutual, right? So Liberty Mutual is a really big company. They have a lot of internal systems. They have a lot of internal platforms, but they also have third-party stuff, which means that data looks different in a lot of different places. My team curates and cleanses all of that in one spot and makes sure that everything can talk to each other appropriately, right? Our customers, so to speak, are other Liberty Mutual engineers, which I think is kind of cool. So if you want to ask me about how insurance meets tech, I don't have a lot of good answers for you. I would consider myself really tech, just generic in that way, just plugged into that company there. And then the last thing I want to talk about is that our services are tier 0. Tier 5 is like, oh, that's cute, have fun. Tier 1 is like, oh my gosh, the world's on fire. Tier 0 is my phone will ring at 2 a.m. if something's wrong, right? So I say that in the sense that the biggest deliverable that my team gives is reliability, resilience, right? Confidence, that's the biggest thing. And that's what I wanted to talk to you a little bit about today with testing, because testing is one of those ways that we can gain those things, okay? Fun little fact about myself. Before I was a teacher, I taught music. I was a band director here in Texas for about 10 years. And I don't do that anymore. Now I do tech stuff, so. Why am I here today? Well, when I was making that career change, I was very fortunate. I had a lot of people that were actually in that similar boat where they were used to be teacher, then they moved into tech. And I had the luxury of talking to a lot of people that were recently entered the field or had only been there for a few years. And I asked them, I was just like, I'm not necessarily how do I get hired? Because I know how to get hired, right? It's just when I do get hired, how am I going to be set up for success? What do I need to be doing now that when I get a job and I'm on a team, I'm doing good stuff and I'm being providing value, right? Overwhelmingly, the answer is testing. I think there was maybe one other answer, and I don't even remember what it was because it wasn't as relevant as testing, right? Every single person that was new to tech that actually got a big boy job, right? They got their butt kicked by I don't know how to do this. I can do this, I can do this, I can do this. I show all the things in my resume or my projects, and they asked me to do a very simple thing, and they couldn't do it as well as their teammates, all right? A couple little early career experiences that demonstrate that value of being skilled in testing is that one of the jobs I interviewed for, I did not get the job, the technical aspect was actually really fun. It was, looking back on it, it's fun, but in the moment it wasn't. The technical aspect of that coding challenge to show them I could code was actually testing based. They showed me code that already worked, a feature that was already done. They asked me to build a test for it. And then they also kind of did another thing that was a test-driven development type thing where they say, the code doesn't work and the tests are failing, figure that out. But that was really the element. It wasn't a leak code challenge. I thought that was pretty unique. And again, I hadn't sharpened those tools. I showed them that I don't know how to test, and they're like, well, then you don't get the job, right? Moving on. So when I first got hired at Liberty, another experience is that the program that I got hired at with Liberty, it's this 4-week intense training on their tech stack and on that. And alongside of that is you're building a project. And my team got really special recognition because we not only built the deliverable, but we also tested it properly and had a really good code coverage to show them. And then lastly, I started a new team at Liberty early this year, January, and testing is how I really onboarded. Like that was like the easiest thing for the team to like. I mentioned the importance of the work that they do. This was the stepping stone for me to get onboarded, right? It helped me learn all of the different code bases that we have. It helped me learn our team standards. And then personally, what I think most importantly is like, this is what allowed me to show my team members that like, I kind of know some stuff. Like I'm new and I'm young, but like, I'm not like dumb, right? No one's dumb here, but you know what I mean, right? Like that feeling of like, I know so many things and you don't know that I know things. And I want to be able to show you this was a very easy way to do so, okay? Some goals for today. I want you guys to better understand why unit tests are important and the value that they could provide for your services. I want you to understand what constitutes a quote unquote good test versus one that doesn't, because having tests to just have tests and get green check marks, I don't know, just use emojis if you want that validation, but like you want actual value to your product, right? And the last thing is I want you to have a couple tools in your toolbox on like how to actually get started, because I feel like, again, whether you went in a traditional or a non-traditional education, that's not something that I think is as valued as it should be in a practical sense of working and contributing to a development team. So, first things first, what is a unit test? A unit test is where we focus on one portion of your application in complete isolation, right? It's a class, it's a function, it's a layer. You try your best to only work on that little chunk of code, right? And it differs from integration tests because integration tests are kind of like the whole thing, right? It's about how all the things interact with each other, and you're kind of testing those interactions rather than the individual components that are linked together. You can obviously see that with the units would be each little chain in the link fence, right? Why do we unit test? My best answer to that is that it's not for you, right? You know that your code works. It should, right? Hopefully, at least on my machine it does. That was a joke. Okay. It's not for you guys, it's for other people. You work on a team, and then eventually you're gonna leave that team, all right? And someone else is gonna come on, and they're gonna work on a feature, and then they're gonna change your code, and they're not gonna know all the negative side effects, or not even negative, just side effects in general that might happen on this large scale application. Your unit tests are little red flags to raise to say, hey, the code that you just changed, it affects this place over here, right? That's the biggest value I think that a unit test could provide. And my reasoning for you should put some oomph into this. You should invest into this skill a little bit, all right? This ensures that any future code doesn't have any negative side effects. Unit tests also verify that your code functions the way it needs to. And every once in a while, it catches something that you didn't think about, right? An edge case, a typo, things like that. Or Copilot's a little bit smarter than you, and you're like, oh, yeah, I didn't think about that. I'll add that in real quick, It helps you in that way, okay? What makes a good unit test? This is a bit subjective. This is a little bit more of a gray area, because different companies and different people and also different products, like they're gonna have different standards, right? You're gonna have different methods. There should be some universal truths to it all, but it should and could and probably will look different, right? So it's about following your leaders, and on your own personal projects, you setting your own standards for what works for you and with that project, okay? Some universal truths, quote unquote universal, right? Tests should be dumb. And I say that in the sense of like, you don't need to like do this crazy complex thing, all of these different assertions and whatnot. You want to test a thing, right? I want it to be dumb. I want to say it should do this and only this, right? And that's one test. Because like I mentioned earlier, if there's a negative side effect and it's only affecting that one thing, it helps you debug and it helps you move into the future, okay? Quality tests are what deliver the value, okay? Quality over quantity. So a little bit of a hot take, 100% code coverage. If you guys have ever seen it, has anyone never seen a code coverage report or know what I mean by that? I'm going to assume that we all do. Okay, so engineering managers love to see that. I want 100%. I want green all the way to the top. Yeah, you should have a high percentage, like 80-ish, right, or above, right? But don't necessarily equate 100% code coverage to like, I have an ironclad, non-breakable code, right? Because we're going to talk a little bit about that as well. It's like quality over quantity, okay? That's where the value is delivered. Here's like the very most basic structure of what a unit test would look like. I break it down into 3 things, right? You have your setup, all the stuff you need to set up this testing environment or this test in general. You actually have to call the method, and then you have to assert what should or should not happen, right? Those are the bare bones, the 3 things, all right? So we have this add to method, this extremely valuable code, this method that adds to, right? So my setup is that I just define the number that I'm going to start with. I define what I hope the return value is after I invoke it, right? And then I actually call it, and I save that to what it's actually going to be called. And then I have my assertion here, which is that I assert that what I expect is equal to what it actually is. That's like the most basic format of them, okay? Here's your little cheat sheet. Like if you guys have these in your back pocket, like this is pretty much gonna get you a lot of the way, right? So just some very basic assertions are like this is equal or this is not equal when you're comparing 2 values, that this is true or this is false, this is null or not null. A not null is a little iffy because it's like if something's not null, it could be a million different things, but that's assertions available. This last one's a little bit trickier. This is you're asserting that an exception should be thrown if something happens, and you can see that that setup and that call is kind of in the same thing. We're going to talk a little bit more about that later. And then we actually go down over here for these Makito assertions, which is what we're going to be talking a lot of in the demo today as well. And this is verifying that a method was called, that it was called a specific amount of times, whether it was ever called at all, or it was called with very specific things passed in as arguments. So you guys can see there's varying levels of how specific you can be with these assertions. That's, like I said, if you get these in your back pocket, put that in your cheat sheet, this is gonna get you a lot of bang for your buck on that, okay? When I first started, I kept hearing this word mock, and no one told me what that meant, and I didn't know what it meant, and it was a struggle for me to try to figure that out. So I'm going to hopefully make that super clear if you guys don't know what it already is right now. Okay. So remember, when we're talking about unit tests, we're talking about testing things in complete isolation, right? Nothing else. So even in the most very basic APIs, like classes are going to be calling each other, layers of the API are going to be interacting with each other, and that does not allow you to test in complete isolation. So what a mock does is it creates this fake version of something, a class or a layer or whatever, and it allows us to hijack that call a little bit, and that gives us some control over it, right? So it allows us to run the actual code of what we want to test, but anytime it tries to touch a different thing, we basically fake it. We put a fake version of there, and it doesn't actually touch that code. It touches our fake version that we've controlled over, right? And well, here's a diagram. So let's talk about it here. So a very, very, very basic API. The user is going to call it. The controller will intercept it. It will call the service layer to do some business logic. The service layer will call the repository to then touch the database, and then things are returned, right? Very, very simple signal flow. So if I wanted to unit test my controller, what I do is I mock the service layer. And then that way I can call the controller. I'm using the controller code completely as is. I haven't done anything to it. But when the controller says, okay, now it's time to touch the service layer, it's actually touching the mock, right? And that allows us to control everything else. I'm going to briefly go over this because we're going to get to this in the demo here, but this is just some kind of documentation stuff. So sorry, for time's sake, I'm going to skip a little bit past this. Just some simple Java annotation type stuff that we'll talk about in a second. And you can look at the slides later. Here's a very basic version of that, right? So we have our controller. This is like the diagram I just showed you. We're going to inject the mocks of the controller. We're going to mock out the service layer. And then my test is that I'm just testing when I call the controller, the service also gets called, the service layer. And you can see that, like I have this on line 26. I set up this value of players, right? And then I define that when this method of the service layer is called, I want you to specifically return what I instantiated on line 26. On line 30, I actually call the controller, and I assert that even though the controller was called, the service layer was touched, right? The mock was interacted with one time. You can also see that as well, okay? Cool. Tips on writing tests: don't mock yourself. You want to test that code in complete isolation, so you actually want that code to run, right? Second thing, make it work, then make it better. You don't need to be clever. It can be long and verbose, and it can be muddy, and you can clean it up later, all right? And we're going to talk a little bit about that. I don't have an example of factories today, but factories are basically little quick classes or methods that you can use to just instantiate fake data to interact with a little bit more. There's blogs and YouTube and all the stuff that you can talk about factories. And then here's this last thing. This is kind of want to focus on here is that a good way to get started, if you look at code and you're like, I have nowhere to begin, this is where you should begin, right? This is a good starting point. Comment everything out, return null, and go step by step, block by block, and say, what is this code supposed to be doing? Write a test for it, uncomment the next block until everything is recommented in. Does that make sense? Cool. Tips on assertion. What was called? What was passed in when it was called? How many times was it called? What was returned? What happens when a call throws an error? Those are the questions you want to figure out. And those are the types of things that should be in your code base, right? This is going just beyond that happy path of like, I passed this in, I get this, it passed, it worked. What happens? Everything in between there, okay? So for demo purposes, all right, we work for the NHL. They have this new application called Free Agent, and it's for the general managers of all the teams. They want to be able to sign players. So there's this database player, all right, and you want to be able to go in and sign players, right? Instead of making phone calls now. Here's, sorry, let me real quick on this. Okay, cool. Our sign player functionality, this is what it's gonna look like. We're gonna try to unit test this, the service layer, okay? And I lost my mouse, there we go. Okay, cool. So when we are gonna unit test the service layer, you can see that all of these other these golden ring ones now we're going to fake out all those interactions, and we're going to mock the token. We're going to mock the team repository and the player repository. We don't use the controller anymore, okay? Just a quick reminder on the three things that we should be focusing on how to get started. I want you to focus on what the code is supposed to be doing, comment everything out, go block by block, make it work, then make it better, all right? So without further ado, here's our service layer. I'm gonna just quickly fire up the application and show you here. If I get all the players, these are all the players in the NHL database, right? I'm gonna be signed in as the general manager of the Dallas Stars because we're in Dallas, go Stars. And you can see that there's a couple different things that we have here. If I can get specific players, and here's what I wanna do. I am signed in and I want to sign this player right here. I'm gonna go into my sign player function, do this, and pad request. What happened here? Boom. Oh, I have the quotation mark. There we go, player not found. Awesome, love this. These are what should be happening, okay? Let's take a look at the actual code of this function, right? The very first thing that we have is we have this team ID that we're gonna be getting from our auth token. Like I'm signed in as the Dallas Stars, so I have that team ID there. The ID that's passed in here, we have to get a target player from our player repository. Then we do some quick validation. Was a player found? Is that player already on my team? And is that player retired? And if not, we can continue. The next thing is that we do is we get my entire team information that we have from our auth token. Then we get our cap space. For people that don't know, in professional sports, some leagues you're only allowed to spend X amount of millions of dollars on players. Otherwise, the richest teams would just buy all the best players and whatever. So the last little validation that we're going to have is the annual salary of the player that I want to sign. Do I have enough money for it, right? That's the validation that we have here. And then if all of that stuff happens, then we call our repository to sign the player, right? Y'all following me? I tried to make it a little bit complex, but enough to where we can get some meat in terms of like digging into a business logic kind of test, okay? So let's break this down real quick. This is what I have set up. This is probably, for the sake of time, I'm going to dive into this. This is probably like a 90% done type version, right? And I'll show you what that last 10% looks like. Well, the first thing is that I annotate the service that I'm testing with that inject mocks, and that's just saying that all of the things I'm mocking, it's telling Spring to inject those mocks into this service layer, right? The other interactions I have here is I have the player repository, I have a team repository, and then that auth token. And you know what? Let's do this here so you guys can see. So here's my actual code that I'm testing. Here's the tests, right? So I can go really quickly, comment everything out, return null, so the Java gods are happy. And the very first thing you guys can see is that I'm just testing, should the team ID, you should get the team ID from the auth token. That's the very first thing I do in this, right? I test that by, I instantiate a player, I set his team ID to something that's not my own, I create a team, I set that team ID to something that's not my own, and then I define what should happen when those mocks are interacted with. When the auth token get team ID is called, I want you to return number 1, right? Because that's mine, right? When this, it's just kind of, if you don't do that at that point, then you get null pointer exceptions, et cetera, et cetera. Then I actually call the service, call the sign player functionality, and I pass in any random UID. And I'm verifying that the auth token mock was interacted with one time by calling this right here, okay? Then I would go in and I would uncomment my next block here. That's my next test. This should call get player with ID with the ID that was passed in, right? You guys see that, the ID that's passed in? Now I want to be able to call that repository with that same value. So in the first one, I'm just testing, was that mock interacted with at all? In this next one, I'm being a little bit more specific. Was this specific mock interacted with this specific data, okay? And you can see I did that here as well with this instantiating a player. I make a UUID. I set that UUID to the player. I set their ID, all this little setup here. And then now I'm saying that when I call this service, I am asserting that the player repository was interacted with one time by get player by ID with the ID that I specifically passed into the call the service with. Okay, and these keep going on all the way down here. I'll make the repo and the slides available for you because I'm a little short on time, but I just want to quickly scroll and get your eyes on this real quick. Do you guys start to see some redundancy in these tests here? I'm instantiating a player each time. Sometimes I'm setting their UUID. Oftentimes, like almost every single test is say that when the auth token is called with the get the team ID, I want you to have it be team number 1, right? Almost every test has this information. And as you uncomment lines, line by line, and you test block by block, you might have to go add that stuff back in. So a more final version of what this test would look like is, let me scroll this over, this one right here. Another thing that we can do here is before each annotation is that I have a method called setup. And I'm not setting everything up for every test, right? I think that this is what's going to differ, service to service, right? But there are some common things that I mentioned, right? So I instantiate a player, I instantiate a team, and then before every single test, I am giving it a random UID number, I'm giving it a team number that's not my own, and I'm setting the team ID to number 1 because that is mine. I'm making sure that when auth token is called, it's going to return 1, and when it's asking for the player by ID, it's returning the player I instantiated. All of these things are happening each test. And now my tests become much more legible for the next person that comes in and works on my code. This test says I should get the team ID from the auth token. Well, I call the service and I verify that the auth token was called. Now it's that simple. Now it's that much more legible. It's a lot more cleaner, right? And I can scroll all the way down here where the cool thing about that before each is that it can be overridden. It happens before. So now when this is called, I can set the status of that player to something else. And now when I test that this should throw an exception if the player is retired, you see that I'm setting that player's status to retired. Now I'm calling it and it should throw an error, and it does, right? Does that make sense, everyone? Cool. All right, and then I know I didn't really get to go test by test, but don't forget to run, oh gosh. Oof. It's because I changed this here. I'm testing everything and it's all commented out. Save that. Now let's run it. Okay, we're still getting one on there, and that's because I think it's the wrong title case, which it is. Forgot I made that change earlier today. There we go. Cool, right? My last little snippet of information is that when you're testing line by line, don't make sure you run the whole suite. Because when you're doing a setup and you're changing things in between tests, you want to make sure that you have all your ducks in a row and you're setting them up each test the right way. Okay? We are out of time, so let me just real quick say thank you to all the people that were involved in helping me grow. Austin Chappell, Mike Matthews, Mateus Talliard, Adam Reynolds, Danny for allowing me to speak, as well as all my fellow speakers here. The Dallas Software Developers Group, they're awesome. They do a really good job of focusing on upskilling developers and connecting them with other people. And then my last little snippet here is that if you're looking for a job and you want to stick out, have your projects, your personal projects, have some code coverage. I think that's a really good way to show that you know how to do some stuff. So thank you guys so much for coming. And if you guys have any questions or want to say hi, come.